learning how to put patterns into practice, what we're going to learn about today is how to look at a polynomial and potentially unpack it and come up with how in the world it can be factored. Now what I'm going to do to start with is I'm going to pull out, I'm going to do the ones from the book because I don't have any good examples, and I'm going to explain them for you. Oh, seriously. All right, here's the one out of A, okay? 3xy minus 4 minus 6x plus 2y. This polynomial doesn't seem to have any common factors other than a 1, nor does it have any patterns, because the patterns we've learned are trinomials, right? We've learned difference of squares, and we've learned sum and difference of cubes. This is a 4-piece polynomial, so there are no patterns that we are aware of. But remember that the order that this is written is fluid, which means I can write it in a different order if I choose to do so. So what I'm going to do is try and find a way to group anything together that seems to share something. Take, for example, these two components. These share a factor of 3 and x, okay? And then I'm going to maneuver my -4 next to my 2y. Actually, I'm going to put it positive 2y minus 4. It's just, I like it better that way. Positive 2y minus 4. Now, let's look and see if there's anything I can pull out of these. We've already said there is. I'm going to pull what? 3x out of this? Which leaves me y minus 2. Would you agree? And what can I pull out of these two pieces?
2.
Positive 2, which also leaves me y minus 2. So is it safe for me to say that both the 3x and the positive 2 are being multiplied by y minus 2? Okay, then I can take the 3x and the positive 2, group them together, and multiply them by the y minus 2. And you now have your completed factor. No, because it's, you don't have to think about it. They're not, because this is not being multiplied by y minus 2 squared, nor is this. Each of these is only being multiplied by y minus 2 to the first power. That's a great question, though, that you might have thought that. I'm glad you asked that. That's a great question. So we basically regrouped, and we're lucky enough to find that both the 3x and the positive 2 were being multiplied by the same factor, which allowed us to group the two items that were sharing a factor and multiply them that way by that factor. I'm going to go ahead and do B with you. Actually, you know what? I think I'm going to do another example like this. AX plus BX plus A plus B. Okay, this is another example that's similar to A. You might say to yourself, well, let's leave it the way it is because both of these share an x, right? But what do these share? They do share a 1, you're right. And that's all they share. There's two ways you could do this. There's leaving it the way it is, which I'm going to show you right now, and rearranging it so you group your A's together. AX plus A plus bx plus b. Both ways is going to get you to the same result. We've agreed we're going to leave it like this for now. What does this share? X. X multiplied by what, folks? A plus b. And what do these both share? Only a 1 multiplied by. So both the x and the 1 are getting multiplied by what? A plus b. Now I'm just going to be honest with you. It doesn't matter how many times I do this. For whatever reason, I always maneuver it so that it looks like this, even though they do share that 1 here. So if you didn't visually see this, but you saw that, the same process will hold. Here and here. What do these two components share? A multiplied by x plus, positive b multiplied by. So both the a and the b are being multiplied by x plus 1, exact same factor. Okay? There's more than one way to skin a cat. By the way, I smelled formaldehyde today. What's going on down there? Anything?
Probably
Skinning cats. Okay. Let's go down to letter B. Letter B, everybody. So you just saw where we grouped in order to try and create two things that were factors. This next piece is slightly different.
Is it b squared or 3?
Hold on. S squared minus 4t squared minus 4s plus 4. Okay. This all shares a 4. This is a square. If I pull that 4 out, that leaves me s squared minus t squared minus s plus 1 times 4. That doesn't really get me anywhere. There's no greatest common factor among all 4, and there is no pattern for 4. However, if I maneuver and move him to the end of the polynomial, I have this, s squared minus 4s plus 4 minus 4t squared. Look at this pretty trinomial. What kind of a trinomial is this? Rhymes with Urfic where? It is a perfect square. Square root of s squared is s. Square root of 4 is 2. If I make the symbol a negative, I have now just factored that component. But I still have the minus 4t squared. This is where mind-blowing is going to occur. Is this piece a perfect square? Yes. Is this piece a perfect square? It sure is. What is the square root of s minus 2 squared? S minus 2. And what is the square root of 4t squared? 2t. And is this sum or difference? Difference, right? This is the difference of 2 squares. Separate it by a minus. And again, square root, and plus. This is the difference of 2 squares now. Yeah, mind blown. Square root minus square root plus square root, right? S minus 2 squared has a square root of S minus 2. 4t squared has a square root of 2t. The difference of two perfect squares is factored by separating them by two different signs, plus and minus. Those are tough, I'm not gonna lie. If you don't recognize them right off the bat, that's okay. They are difficult. I'm gonna do another one with you that is exactly like this, okay? Here we go. X squared minus 4y squared minus 6x plus 9. If you look carefully at this, you'll find there's no greatest common factors, there's no patterns. This is a 4-part nomial, so it's not a trinomial. But you will find that if you move another square, 4y squared, to the end of the sentence, you now have x squared minus 6x plus 9 minus 4y squared. It's almost the exact same thing as this, guys. X squared and 9, are they perfect squares? Can the middle term be created by multiplying 3 by x and doubling it? Guys?
Yeah.
Yes, only if it's a negative though, which means the factor of this perfect square trinomial is x minus 3 squared. Still left with our friend 4y squared.
Get you out to the office, please.
This is now the difference of two perfect squares. Build your parentheses. What's the square root of x minus 3 squared? The square root of anything squared is the item itself. X minus 3. Anytime you're asked the square root of something squared, it's the something. What's the square root of 4y squared? 2y. Separated by an addition and subtraction because this is now the difference of squares. This was a perfect square. This was difference of squares. That was a perfect square, which led us to a difference of squares. Okay, I promise you this type of factoring is the most difficult to grasp because it takes you recognizing multiple patterns. That's just the way it is. It takes you recognizing multiple patterns. So, without further ado,